Hi Bio4 and welcome to part 8 of senses. So we're going to start with the eye right now. Very cool. First of all, I'm going to tell you about rods and cones. So rods provide vision to you when light is not perfect, when it's dim. Okay, and so you have these specialized cells that are called rods, and most of them are going to be in the periphery of the retina. So the sensory neurons are all in the retina, which is like a carpeting of the back of your eye. So think of wall-to-wall carpeting of the back of your eye, and all those are sensory receptors. But the ones that are for the rods are going to be then sort of on the edges, in the periphery of that circle, which the retina is in the back of your eye. And they contain a certain pigment, and that pigment is rhodopsin. So that pigment, when light hits it, is going to react and allow you to have vision, to see an image. The cones are going to work only in a lot of bright light. So you need a lot of bright light for these cells, these neurons, to function. And they are going to allow for color, for sharp color, which is excellent. So in the dark, you're just seeing sort of black and white, and you can see color as long as you have a lot of light coming into the eye. So what pigments do cones use then? Well, there are 3 types. And each of those cones is going to have a different type of pigment in it. And it's the combination of those 3 cones with the 3 different pigments that's going to allow you to see the array of colors that you see. So this is the arrangement of these. Look, you have red, green, and blue. Do you notice? So those are 3 cone types that you find in the fovea. Fovea is just one region of the eye that has hyper-concentrated neurons. So they pick that area to make the picture. But see the distribution here? There's a majority of green and red. Here there's more blue and green. So they're distributed differently than in the back of your eye, and not so much in the periphery, but all over and very concentrated in this one focal region, which is called the fovea. So first of all, what do they look like? So now you can see why they're called rods and cones, right? A cone in a photograph looks like this. It looks like a little cone, and this then cut off like that is a rod. So the rods are larger than the cones, and this is them sort of intertwined, right? And then if we could just make sort of a stylized drawing of that, you would have something that looks like this with a rod, and this is a cell, right? This is a cell, and it's got its mitochondria and its ribosomes and whatever, and it has a nucleus, right? It has a cell body, and then these little synaptic vesicles. So it's not that different from another cell, but definitely not like Joe's cell, right? Looks different. And this one's a little smaller, and it's got that cone shape to it, but it's a cell. It's a cell like any other cell. So how does this work? Well, the retina then, remember, is that carpeting in the back of your eye. So this is the retina, that carpeting there that has these pigmented layer of cells, and then inserted into that pigmented layer of cells are the cones or the rods like this. And then they in turn are going to connect to these other cells, to these bipolar cells. Remember we talked about cells could be unipolar or bipolar? It's these bipolar cells that are going to first captivate light and then pass those action potentials along the cones, along the rods, all the way to the retina. At first it's hard to understand this drawing. You have to remember that they are inserted, then light is coming from here, so that the entry of the eye is over here, and this is the back of the eye, okay? And so this is a kind of arrangement that would be normal of the rods. So rods, remember, you only see in the dark, so these are night vision, and you could have a row of them, for example, that are inserted into that pigmented area in the back of the eye. But then when you see what they connected to those bipolar cells that I told you we spoke about. And then I saw a cell called a ganglion cell. A ganglion cell that's going to connect over to the optic nerve. So light, again, is coming in this direction, okay? And it's hitting these cells first, and those are going to send an action potential over to these other cells. Okay. The other thing I want you to notice is the row here, these rods, and how I have about 3 bipolar cells and 1 ganglion cell. And these are the ones that are feeding into this bunch here, 4, 6, 8, 10, 12, 14, 15 of them. Now compare that arrangement to the arrangement of the cones. Okay, cones, we have 2, 4, 6, 8, 9 cones here. How many bipolar cells? Oh, wow, equal numbers. How many ganglion cells? Equal numbers, right? Let's go back. See, we only had 3 bipolar cells for about 12 or 15 of the rods. And here we have equal numbers. So what does that do? Day vision. There's a lot of light here, right? And I can afford to have each one of these captivate a little bit of light and pass it on to the cone because there's enough light to do that with. Okay, when we're talking about rods and it's very dark, we're going to need the bipolar cells to captivate a whole lot more light and then pass it on to more of these cells because just they need to get more light because light is so low. There's so little light that it's going to need to actually unify and have all of these just logged onto one bipolar cell. It's a method of kind of grouping light together. And there you have them side by side. Okay. So cone sensitivity, these are for color, right? And there are 3 types of cones, and different cones are sensitive to different wavelengths of light that are hitting your eye. So if I have a wavelength of 380 here, I have this blue cone is getting stimulated, but only that one is, right? In this case here. If I have, you know, a wavelength about here, then I'm stimulating both the green cones and the blue cones. And those together are going to give me an image. If, however, I'm coming here, right, I've got the green cones and the red cones, and then, for example, over here is red cone only. So color blindness is interesting because most of the time it's on this red cone that has a problem or isn't functioning or it's not there. So by lacking that, you're going to be able to see different colors about this frequency down in this direction. But anything above that would have ordinarily been covered by the red is not there. So sunsets, my friends, are just not the same. And I always tell the story that I went picking tomatoes once with a friend who was colorblind, and he didn't tell me he was colorblind. And so we go pick tomatoes, and pretty soon Roger's picking all the green ones. It's like, what are you doing? Why are you picking the ones that are not ripe? He says, oh, are they not ripe? Oh, he says, I'm colorblind. I can't tell which are ripe and which are not ripe. So that's a funny story. I couldn't see the red. Some other interesting things that happen in your eye. Sometimes I'm sure you've all felt these floaters. And these are floaters in the vitreous humor, which is the gelatinous filling of the very back of the eye. And it has little impurities, little pieces of cell, or sometimes vitreous humor that is just clumped a little bit. And that forms like a little crystal, and then you can see it. So it kind of floats by your eye and then vanishes, and another one floats by your eye. So they're just floaters. That's what we call them. So let's stop there, and then we're going to move on to how you form an image and what it means to be astigmatic and what it means to be nearsighted and farsighted. So let's stop this one here. Thanks for listening.